So good morning and welcome to Automation Perspectives. It's great to be back again this year. We've got a full house here, so I'm excited to go through the program. So let's get started. We talk about the connected enterprise, and today everything that we have is becoming connected. So think of your own world. You've got a connected car that can provide you information about itself or even when it needs service. You've got a connected home, so you can monitor things on your smartphone, maybe your thermostat or your security system. And so the same thing is happening in industry, and it's the same technologies, mobility, wireless, cloud, they're all making their way into production. And so devices and machines on the plant floor are becoming smarter and better connected, and that gives the opportunity for the Internet of Things. In fact, today we have the Internet of Things in an industry, we call it the Industrial Internet of Things. So we have many things that we're working on today, and we can see the value of digitization and digital transformation. But there's some challenges. Much of manufacturing today is still legacy systems, and many of those legacy systems aren't connected. And in fact, because of those systems, industry experiences about $20 billion of downtime every year. And so there's a significant opportunity there to gain better visibility into plant operations. That's why it's so critical. So connectivity and access to information in new and existing assets is really important if we're going to achieve that vision of smart manufacturing. At Rockwell Automation, we call that vision the connected enterprise. And it's about enabling smart manufacturing for our customers by connecting people, processes, and technologies together. And what we're trying to do is create a real-time production environment that's optimized and sustainable and resilient to the ever-changing conditions it faces. We believe that over the next decade, manufacturing will change drastically compared to what it's done over the prior several decades. And why? Because things are becoming more connected. At Rockwell Automation, we have got our motto of listen, think, and solve. We listen to our customers, and our customers are at different stages of this digital journey, and for some very good reasons. But together we're learning. Blake mentioned the idea of digital pilots. And so we're learning together from those pilots. But I think there's some things that are true. As we all gain a better understanding of what digital means, there are some specific areas that we think we can see value in. Things like long-term revenue and profitability. We think the sustainable business model digital offers can help us with that. New connected systems and business models, or for service models for our OEM partners. And of course, sustainable productivity. All of those understandings are driving customers to move ahead with programs to achieve their digital business outcomes. And for us, it's driving an understanding of where we should make our investments in the digital space. So let's talk a little bit about digital transformation. Digital transformation enables a digital thread throughout the entire enterprise. It allows the seamless collection and analysis of data and the ability to gain that information. It's a digitally transformed enterprise that has all aspects of it connected. That connectivity spans the product lifecycle of all our customers. So digital transformation is the key to designing better products and generating long-term operational productivity. And so there's two concepts we want to talk about. The first is digital design. Digital design helps industrials design better products and bring them to market faster. The second concept is digital operation. This allows those products to be produced in a sustainable and efficient manner. So digital design is in the front end of the product life cycle, and digital operations is the sustaining part over the rest of the life cycle. Both of these methods have an important concept. They allow this idea of the digital twin. And that means that for products, physical assets, or processes, you can create a digital twin or emulation of what those things are. What that means is it allows products to be tested before they're built. It allows production changes to be tested before they happen. And it allows design and performance to be optimized during the production process. After inception of a product idea, the first phase of that is digital design. This is when a product is produced, is designed, processes to produce it are defined, and plants to produce it are designed. Machine equipment and all the information in factory automation systems are designed to help produce that product. And so as part of that process, collaborative design environments are really important. They simplify the automation and information design efforts to integrate disparate tools and workflows together and allow complete systems to be designed and simulated. At Rockwell Automation, our digital design environment is Studio 5000, and it's the center of our integrated environment. Studio 5000 focuses on a digital system approach to design, and it's leveraged through that full automation and information lifecycle. What's unique about our system is open. Information can be changed bidirectionally with our offerings or with those of our partners or other third parties. It makes a more effective design and for better collaboration. This year, we enhanced Studio 5000 by introducing 3 new capabilities that help this digital design concept. The first one is an automation ML interface to other tools like ePlan or other CAD systems. The second one is improved connectivity for our emulation environment so that users can do operator training with other systems like Mina or Cape software. And the last one, but not least, is an OPC UA, open and unified connectivity for all our software products. This week, we're going to demonstrate these capabilities out on the show floor, and you're going to have a chance to be part of that demonstration when we have a mixed reality digital twin solution. We have a great OEM partner, Kama Group from Italy, that helped us put this together. And it's against a virtual backdrop of their latest and greatest world-class packaging machine. And so the machine incorporates the latest integrated architecture technologies, new innovations like independent cart, and real-time analytics. And all of you will be able to interact with that machine and its design by using a 3D model of the machine and Microsoft's HoloLens. So mixed reality is important because it helps folk work differently and interact with their designs during that design process. And you can validate the designs and concepts long before they go to production. So it's a great demonstration. Take a look at that when you're out on the floor. You know, it's a great digital design that can help products come to market faster. And if that's true, using proven libraries of automation building blocks will help accelerate time to market. Our machine builder libraries help OEMs to move away from traditional methods of programming to modern ways of creating automation systems. So the designer shifts from writing code to proven libraries of machine functions that help them design their systems. So it's more drag and drop than it is programming. These libraries are automatically instrumented. Advanced data models containing device and machine information and linkages to that digital operations environment I talked about, enabling advanced information and analytic capabilities. So the whole concept, again, is everything is connected. Now, once product design is complete, digital operations allows products to be produced in an efficient and sustainable manner. During this phase of the life cycle, typically lasting a decade or more, so design typically lasts maybe a year or two, this phase, a decade or more of production time, there's a huge opportunity to impact profitability. And so when we talk about digital operations, we think of it in 3 areas. The first area is information management. It's kind of the connectivity, data collection, and orchestration and open platforms for software analytic applications. The second area is operations itself, traditional things like driving work orders, production goals, managing assets, and making quality products with less risk for the enterprise. And the last but not least is keeping production running. It's about maintenance, troubleshooting, and technical support. And so we want to talk a little bit about how these 3 areas can help a customer impact their operations and drive sustainable production. So I mentioned earlier how we're working with customers on digital pilots to advance their digital transformation journeys. You know, those pilots are doing a couple things for us. The first thing they're doing is helping us prioritize which outcomes have the greatest impact. They've helped us actually define the first, what we believe are killer apps that have the best return on a customer's digital investment. And so to simplify this a bit, we've defined 3 value streams. The first value stream is asset management and reliability. So think of things like predictive maintenance or prescriptive maintenance. The second one is operational productivity. Remember that 10-year life cycle I talked about? So operational productivity helps drive effective efficiencies throughout that production cycle. So think overall equipment effectiveness maybe, or production throughput. And the last area is risk management. And so think about safety systems, information security systems, and other things, track and trace, serialization. Each of these 3 value streams represents in one way or another the learnings that we're having with our customers and in the market. And so we use those to characterize and prioritize our approach. Now, our approach to delivering these value streams is a little different than our competitors. So in our world, we're the world of real-time data. That starts down at the intelligent asset in the machine. It doesn't start in the cloud. The cloud is merely a tool to help produce an outcome. And so down in that real-time world, we can close that digital loop. And so we can understand what's happening, we can run an analytic, and we can have an impact on the production of the customer immediately in real time. So we're on a mission to combine our understanding of the market needs, our technology, and our domain expertise to make a powerful industrial analytics platform. Powerful, but easy to use. And so we're investing in real-time, open, scalable analytics, a platform that will allow our customers to scale across that entire information architecture. Analytics on a device, analytics at a machine, analytics at a line, in a plant, and in the cloud. Decisions made closest to the source of the data where they can have the biggest impact on results. Last year on this stage, we showed you some early innovations. In fact, we showed you a demonstration. These were the first steps in our mobility and collaboration and analytics platforms. And so we demonstrated FactoryTalk Team 1, our mobility and collaboration platform. Then we showed you how to take Team 1 and combine it with FactoryTalk Analytics for Devices, our device health and analytics offering. And then we showed you how FactoryTalk Analytics for Machines, a cloud-based analytics platform for machine builders, come together. So this year we're going to introduce a new set of capabilities to our FactoryTalk Analytics platform. But first, let's take a look at how those innovations from last year are doing. So our customers are voting for Team 1 with every pinch, zoom, touch, and swipe they're making. In fact, we're tracking excellent download growth, but also active daily users. And so it's not just folks downloading it, but it's actual teams who are using the offering. And so to date, we've had 13,000 downloads and almost 5,000 teams created. These users have connected to over 200,000 devices. So we've also released 10 updates to Team 1 since last year, including new capabilities and improved workflows for those users. FactoryTalk Analytics for Devices, our first analytic appliance, has also gone to market just recently, a few months ago. You might remember last year when we did our demonstration, we had a bot called Shelby that we interacted with. So since that release, we've got 250 units in the field, and they're monitoring over 25,000 devices. So if you think about that, and on average of maybe a dozen capabilities per device, Shelby knows how to do and analyze 16,000 different configurations for our customers. And it turns out that Shelby can talk to more things than just Rockwell Automation devices, and you're going to see that out on the floor. We're allowing partner devices to participate in the Shelby Analytic Appliance. The first partner is Festo, and those devices are available today. So over the next year, you're going to see many more analytic edge devices and appliances joining the FactoryTalk Analytics platform. Scalable analytics that close that digital loop in real time closest to the source of the data. Now, I mentioned earlier we're introducing new capabilities for the FactoryTalk Analytics platform. And so over the past year, we've invested in new technology that really makes our scalable analytics vision come to life. Our internal name for this project is Project CEO, or Latin for to know or to understand. CEO is an advanced analytic and data orchestration offering. It can run on multiple scalable compute services, everything from intelligent devices all the way to the cloud. Because remember, in our world, that real-time information architecture is important. So let's take a look at these new capabilities. And to help me do that, I'm going to introduce Andrew Ellis. Andrew is the manager of our commercial engineering group. Commercial engineering helps customers apply our information and analytics platforms. So Andrew, welcome to the stage.
Thank you very much, Frank.
All right,
Glad
very
to be
good.
here. Morning.
So Andrew, you know, last year we were up here and I joked around that the demonstration wasn't working the night before because it really wasn't. That added a little excitement for all of us. This morning I came in and Andrew said that our Azure instance was down, so that added a little excitement too for all of us. But we've got that up and running. And so Andrew's going to talk a little bit about what analytics are, and then we're going to do a video,
Yep.
and then we'll have a little bit of discussion after that. So
Exactly.
Stage is yours.
Thank you, Frank. Good morning, everybody. The first slide we have here is Gartner's classification of analytics. And starting from the left, we really have descriptive and diagnostic. Think of these as your basic analytics. And then predictive and prescriptive as more advanced analytics. Traditionally, when we think of analytics, we're looking at historical data. So systems can tell you what happened and with a little bit of information tell you why it happened. So for example, my motor stopped. Okay, that's descriptive. My motor stopped because of an overload relay trip. That's diagnostic. This is the world or the domain of historians and tools like our FactoryTalk Vantage Point. But it still requires the user to interpret the data in order to make a decision, to take action in order to improve operations. For manufacturers who are trying to endeavor to be more competitive and truly maximize their utilization of assets, they need to adopt advanced analytics. These are tools that look for trends in data that can leverage model-based algorithms in order to predict future events and have those events fed back into our control systems in real time in order to prevent costly downtime and quality issues. Advanced analytics is the world of machine learning and artificial intelligence, and is really providing a game-changing production benefits for manufacturers. So before I go to the next slide, I really want to frame up our strategy and why it's so important to our customers. I'm going to start with a question. And that question really is, when we look at traditional analytics, what is the challenge that's there? It's not a lack of data. We have lots of data. When we think of manufacturers and processing facilities, they have tons of data. Real-time data, transactional, time series, and whether that data is sitting in files and databases and proprietary data stores, it doesn't matter. The lack of data is not the issue with us addressing analytics. The challenge to achieving advanced analytics is to be able to process that data, cleanse it, enhance it, and stream it, and form it into a tool that can be consumed by an analytics tool and then provide insights to our customers. This is the challenge that our new platform will address. So now on this slide, I want to talk about our architecture. So it's three components, three main pillars. On the left-hand side, we have data ingress, we have data orchestration, and then finally, data visualization. So let me start with data ingress. Think of this as your traditional data sources, whether they're third-party or our Rockwell Automation data stores. So things like FactoryTalk View, Alarms and Events, Historian, Energy, Metrics, Production Center, all those data stores are prime candidates to move that data into our Elasticsearch database in order to build analytics upon. In addition to our data ingress, we're adding a new capability called the Edge Analytics Platform, EAP. And what it will do, it's a small piece of software that can connect to real-time systems, time series data, transactional data systems, and be able to add a layer of compute and analytic as close to the data source as possible, and then store and forward that data to our Elasticsearch database. And as the name indicates, Edge, it can run at the edge, for example, in our 5480 controller, or all the way up in a server in some server farm somewhere else. So that's data ingress. And now I'm going to move way over to the right and talk about data visualization. And when we say analytics, I'm sure we all have the same vision of cool dashboards, widgets, gauges, and trends. And no different here. We're going to provide a self-service portal where users can develop their own analytics on top of all the data coming from the left-hand side. We'll also build applications to meet our customer needs. But the real secret is in the middle piece. This is the game changer for both us and our customers, the data orchestration layer. This is where we can mash up data from different sources. So imagine taking some operations data, some energy data, and some historian data, and blending it together, staging it such that I can build analytics on top of it to truly drive insights for our customers. This is the real value. This is what will help our customers achieve those advanced analytics of predictive and prescriptive analytics. So those are our three pillars. So at this point, like Frank said, what we're going to do is show you a short video presenting Project SEO, which is part of our analytics platform family, and then Frank and I will come and do some demos. So with that, let's cue the video.
The availability of data has revolutionized how companies solve issues and adapt to changes. But gaining value from production data takes time and often requires special expertise. Rockwell Automation's Project SEO, the newest addition to the FactoryTalk Analytics platform, can help you overcome these challenges by allowing any user to securely access any existing data source to create personalized, actionable information. Let's take a closer look. In the traditional approach to machine learning, each device is manually mapped, which is a time-consuming and error-prone process. Project CO automatically discovers devices, giving users access to more detailed information, including things like device name, line location, and plant location. Upon login, CO provides immediate access to a rich set of storyboards that turn raw data into usable information for making data-based decisions when and where they matter most. Creating a storyboard is simple. The first step is to ingest the data. With so much time spent gathering and preparing data, CO enables you to easily pull structured and unstructured data from any existing data source. The data is seamlessly pulled into the platform with the ability to modify as needed. With the click of a button, the system orchestrates, organizes, and visualizes the data, and a new storyboard is created. This enables users to perform advanced analysis, solve problems, and drive tangible business outcomes. CO puts analytics to work for everyone. In addition, CO can intelligently fuse related data from virtually any existing source in your enterprise, giving you insights not possible before. Built for ease of use, CO eliminates the need to involve IT in creating a workflow. The intuitive interface, combined with the platform's pipeline capability, allows you to design a workflow using simple drag-and-drop functionality. Data exists everywhere throughout your operation. With the right tools, you can transform it into useful, actionable information. Project CO turns your data into the reporting, dashboards, and advanced analytics you need for apps that drive value and informed decisions. Learn more. Contact us today.
Right, so that's Project CO. And so we thought what would be interesting is for Andrew and I to do some demonstration. So we've got an instance of CO running in the cloud on our partner Microsoft Azure's platform. And that wasn't the connection Andrew just made, by the way. But we thought it would be interesting for us to explore a couple areas in particular. Andrew, we talk a lot about analytics. We talk a lot about our platform. And we talk a lot about simplification. The things that we learn with our customers, not just about the use cases they're trying to solve, but some of the challenges they face in implementing these things. Because sometimes it's not easy. You mentioned data and information management. Data scientists, we talk about those folks, but they spend most of their time cleaning data, right? And that means they spend time and time again with very specialized skills. But CO is a little different. We talk about ease of use. And so I thought ease of use is going to be a really important concept and a really important capability for our customers to be more successful on that digital journey we talk about. So can you show us a few examples of ease of use as regards to CO?
For sure, and this is the fun part of the presentation. First of all, to answer that question about the data science, I think that's very important because now we're going to give them time to focus on the stuff they probably really like. Because I think I heard a stat that was 60% of their time is used in cleansing data as opposed to, I'll say, doing real work. So on that note, what I want to do is kind of go through a demonstration of how to ingest data, so how to bring the data into our system, as well as in how to mash the data together. This is the real challenge of doing any type of analytics, is blending two different data systems that come together. How do we do that? The example I'm going to use here is from a caster operations, where I've got some caster data where they're making billets, and I've got some lab information system that tells me the chemistry of that billet, and the user wants to blend this data together. So I've already got my caster data in here. I'm going to add the LIMS data and then mash it together. So what you're looking at here is our CO platform. This is our self-service platform where you can come and build your own applications and analytics. What I'm going to do is go New Report. And what I'm getting to here is really I'm going to ingest the data, and I can pick various data sources. I've simplified my view for this demo. There's lots of different data sources we can look at, and I've picked Excel. So for me, the LIMS data or the lab data is coming from this file right here. And I want to bring that into the system and then blend it together or mash it together.
So are there any limits to the types of data that you can bring together here, Andrew?
There are no real limits. The benefit of Elasticsearch database is it's a repository that can accept almost any data type.
So real-time data, transactional data, different data sources, and different data types.
100%. So what we're doing here is walking through the steps of ingesting this file. This file could be 100 records long or millions of records. And at this point, what it's asking me, it's gone through and looked at the data source, in this case it's an Excel file, and said, hey, here's the sheet name, here's the column names. Do you want to adjust those display names? Here's the data type, you can change it here. Do you want to change the visibility so certain users can see it or not? And I'm just going to simply say next. It's going to give me just, this is what it will look like, and I'll say finish. And this is where the real secret sauce is happening. Because behind the scenes, it took that data, ingested it into our Elasticsearch database, and made it available in a performant manner for other users and myself now to start using. So here I've got, the other thing it's done is based on the data it saw, predict for me the 4 types of analytics that may be useful to the user. I can go and change these and enhance these and add any other graphics as I want, but it made a first pass, so it makes it easier for me.
So just for full transparency with the audience, Andrew, you're not a data scientist, are you?
I am not. I'm an engineer.
Okay.
Close.
And so most of the folks in industry that understand what's happening on the plant floor aren't data scientists. These are folks who know how to connect to that industrial real-time data. And so we think they're going to play an important role in using these tools to drive those business outcomes.
Definitely. So now let's kind of finish the second piece. So I've got some operations data already installed. I've just added some lab data, and I need to mash these things together. So I'm going to come back to my new report here, and I'm going to pick this new tool called the mashup. And let me kind of get rid of the defaults. And really what it's saying is, first pick what's the first data set you want to pick? And I'm going to pick my caster operations data. That was already pre-done for us here. The next thing I want to select is, what's the unique ID that helps me identify other data sources and I can link them together? So for a caster operation or integrated steel mill, that's a heat. And I can now select this auto join, and what it's going to do is go interrogate our database, our Elasticsearch database, looking for relationships that match up to our heat ID. And it's found 3. Now, the first one I know is the one I want. This is our caster lab data. And if I take a look at it, I can start to see, yeah, this has got the manganese, the borons, the calciums, the things I would expect in a lab information system. I'm going to simply say link. And what's happening behind the scenes, it's mashing those 2 data sources together and providing me with, again, 4 example analytics based on that combined data set. I think that was very simple.
Well, it's simple to me as well. I could probably even do it. But
next year you can do it.
Yeah, but that's why I have Andrew, right? And so what's interesting about that too is those visualization environments become intelligent as well, right?
Correct.
Because they're linked to all those sources of data.
Correct.
You know, that's a great example, Andrew, of ease of use. Listening to the demonstration, though, there was another thing that came out at me. And if you think about the folks who are going to use this, they're going to need some good tools, and some tools that are what I would call modern and contemporary, that kind of speed time to value. And so can you show us a couple examples of a few tools that CU has?
For sure. So again, sticking with the platform here, I'm going to open up our MightEQ's cookie company. I'm hoping everyone knows what this is. If you come to the show floor, it is prevalent everywhere. This is our fictitious plant that makes 4 different types of cookies. And what I've got here is a production analysis storyboard. And again, think of storyboard equivalent to dashboard. And this is a data set that has been mashed together from various data sources. So now I, maybe as the energy manager for MightEQ's, can start to consume this information, and not just as the dashboard as it is, but start to ask questions of it and to drill in. So the 2 things I really want to show here, I'm going to focus in on this top bar chart. So what this is showing me is energy consumed over a period of time when I make these 4 different types of cookies. And I'm interested in, when I hover over them, I can see that when we make chocolate, we run a little higher than the others. And I want to find out why.
Well, you know why, because chocolate tastes better than all the others.
We're making lots of them, no doubt about it. So let's drill in and see if we can find more information. So I'm going to use just simply tools out of the box answering Frank's question. I'm going to drill down, and what I'm presented with is a list of attributes that are part of the data set behind here. And maybe not all of those attributes are used in this storyboard, but I have access to them. So I'm very interested in understanding, you know what, do each of our line operators, when they make cookies, do they run it the same way? And are there opportunities, is there low-hanging fruit for me to maybe have them follow standard operating procedures to ensure we have the same level of energy consumption? So when I look at this, here is now a graph of energy consumed when producing chocolate sliced by operator. And I can see right away, well, there's one that needs to get a promotion because he's using very little energy, or she is. But I've got two outliers here at the top. This is an opportunity for me to go talk to those people and find out, are they following procedures? Why are they consuming so much energy? Because that is an opportunity I can use to hit my target of reducing some energy.
So this idea of dashboarding is interesting because this is active dashboarding.
Exactly.
Right?
Yeah.
And so not only does CO organize the information, provide you particular visualization options, but also allows you to query that information in the context that it was presented. And so it's not a static dashboard anymore, it's an active dashboard.
Exactly, and you're getting now insights. I mean, you think if this chart was not on the dashboard, I was able to derive it simply by using the tool. So the other piece I want to show, Frank earlier talked about our introduction last year of FactoryTalk analytics for devices. And we really talked about the introduction of something called the Shelby bot, where we could ask Shelby questions, and it would tell us based on the information it knew about the devices and their health. That similar technology is embedded here, and we call it intelligent search. So I'm going to come over to the right-hand side. There's a little kind of magnifying glass. And at this point, you can imagine I'm talking into it, but I'm going to type into it. And sticking on the theme of energy reduction, I want to find out, you know what, I want to say, what's the sum of energy? I'm going to spell it right. This must be the American version. So sum of energy by, that's what I wanted, by, let's say, machine. Because I no longer want to look at it when I make cookies. I want to find out maybe a different way to look at this problem is to say, hey, is there a machine that's consuming more energy? And I can fix that, and that'll fix it for all of my cookies. So what I've got here is now, on the bottom are the different machines that make up my production line. And I can see right away that the shrink wrapper down here consumes the least amount of energy, and that makes sense. The shrink wrapper only runs when there's a full pallet in front of it, and then it produces the skid. But I'm wondering why the cooling tunnel and the wrapper are consuming the most amount of energy. I would have thought it would have been the oven, which consumes a lot of gas, but in this case, it's these two machines. This is insight that I didn't have, and I was able to ask questions of the data in order to derive those insights.
So CO has an elastic search capability.
Correct, yep.
Which allows you to use natural English to search for a variety of different outcomes.
Correct.
And provides that same capability of information dynamically, so we don't have to build dashboards to look for information.
Correct.
So that's a pretty big deal, especially for folks who are maybe operating the machine or maintaining the lines.
Correct. So those are the two of the, I think, the tools that really stand out as far as drill down and the whole natural language search, because these really extend the data beyond what the storyboard was originally designed for.
Right, exactly, and they provide even more information to those folks when they need it dynamically.
Correct. Yep.
So the last thing that I was thinking about was analytics. We use the word analytics pretty freely. In fact, we talk about all different types of analytics. But you mentioned that Project CO has capability for advanced analytics. And I think you said both predictive and prescriptive. Mm-hmm. And so that sounds interesting. Can you give us an example of predictive and prescriptive analytics?
For sure. I will give you a bit of a teaser. Let me switch over to another system.
Because you remember what Andrew talked about. He talked about informational, then diagnostic, then prescriptive and predictive. That's where we want to head, right? That's where the big value is when you get to predictive and prescriptive analytics.
Correct. And also to kind of add to that, it was the data orchestration that really was the thing that prevents many users from getting to the predictive and prescriptive analytics. So here I'm logged into our data orchestration tool, and I'm going to select, and I'll give you a background story here once I get this up. But this is a pipeline workflow of manipulating data. So the story behind this is, imagine I am a wind turbine operator. My sole purpose in life is to maximize product output from every one of those wind turbines. And I do that by ensuring that that nose cone of the wind turbine is aimed correctly into the wind, and that the pitch of the blades is correct to capture as much wind as possible. Now I have an algorithm that does this. And what this is doing is actually implementing that algorithm. Now the inputs are things like wind speed and wind direction, as well as the control settings, the current control settings of all my wind turbines in my farm. So on the left-hand side, you see wind speed and direction. This could be coming from NOAA. It's forecasted data, so it's not just what's the wind speed now in the direction, it's what will it be over the next few hours, answering more of the predictive and prescriptive type of analytic.
So that would be an example of a different data source, kind of
Correct.
like the mashup that you did earlier.
Correct.
Right.
Right. So this is data that's not in our system. We have to go outside into NOAA and pull that data in
Right.
and leverage it.
And it's going to integrate with the algorithm in the automation environment to do some prediction.
Correct. So what we're doing here is we're taking the wind speed and direction, as well as the current control settings for each of our wind turbines, bringing them in. Each of these bubbles is performing a function on that data, till eventually we union it together, perform some more calculations, until the end result is a set of output settings for each of our wind turbines based on the current speed of the wind and the direction.
So we're closing that digital loop between that automation environment and that information source that you talked about. And it looks to me a fairly user-friendly and easy way to depict it on a screen.
Correct. Yeah, that's exactly it.
Great. So that's an interesting example in the real world of the things we talk about in real-time scalable analytics.
Right.
And so that's why I mentioned earlier that Project CEO really helps us kind of close that loop on that project that we have. Andrew, great demonstrations.
Excellent. Thank you, Frank.
Thanks for your
Appreciate it.
help. So we're really excited about Project CEO because it helps us bring that vision of real-time analytics to life. We're so excited about CEO, we're already running pilots with customers. And so it's a fun and active time for us. So Andrew, thanks again for the demonstration, and a special thanks to the customers that we're working with on those digital pilots that are co-innovating with us. It's really exciting to see the value we can provide them with these solutions as we bring the connected enterprise to life.